Okay, so hello everyone again. This is lecture 6 part 1 of wave optics. Today we will be going with the further discussions of Young's experiment and then we will go to diffraction concepts. So I am Sameer Lavankar. Let's begin our discussion. So before starting the discussion, let me go on to the course outline. So first of all, we started with the introduction, that is the why is there a need for wave theory, how it is different from the Descartes theory of light. What are the things which are different in wave theory and Descartes theory, as in refraction laws and reflection laws, how it was being assumed that the reflection after refraction law was being proved correct, it was proved that light can be a combination of both, that is a light can be a combination of Descartes theory also and a wave theory also. It can either go as a particle theory, it can either go as a wave theory. Then after this we understood the second point, that is Huygens principle. In this we studied the concept called as wavefront, and then if we need to calculate the value of wavefront at some time t is equal to t, given that we know the value of wavefront at some time t is equal to 0, we can directly calculate it. So that was Huygens principle. After this there was an application of Huygens principle in which we tried to calculate the refraction and the reflection laws. So refraction and the reflection laws were being proved for the light waves using the Huygens principle. After this third point, we understood the concept of coherent and incoherent addition of waves. So coherent means intensity is maximum, incoherent means intensity is minimum. So by color wave we can say it is a bright fringe, and incoherent is nothing but a dark fringe, or the intensity is 0. Then next we are right now in the fifth concept, that is interference of light waves and Young's experiment. So first of all we understood the concept of what is interference, and then we understood the Young's double slit experiment. Now moreover we will go through one of the discussions in which if we change the source, if we change something, if we change it to monochromatic light, so that what will happen to the screen's fringes, will it change, will it differ, if the central bright fringe will deflect from its position or not. So some discussions are to be done so that this concept is understood more, and then finally we will move to two different concepts, that is diffraction and polarization. Okay, so now without any further, let's go on to interference of light waves and Young's experiment. So this was being explained to you in the last class only, that interference fringes are being formed. So these are known as interference fringes. Then next point was ki there were two slits. Please make sure that these slits, two pinholes, were very close to each other. This is one of the important assumption being explained when the Young's experiment is being done, that these two slits S1 and S2 are always near each other. So these are always near each other, very close to each other. Very close to each other. Okay, so this thing was being done. So by Young's experiment we can find that the phase is being logged now. After phase is being logged, so for interference, so to find out the bright fringe we use the concept of S2p minus S1p is equal to n lambda, and finally we got that for constructive interference, that value of x, what is that value of x being talked about here, this is that value of x from the center position, that is point O. So this will be equal to n lambda capital D by small d. So please remember this formula, that for constructive interference x should be equal to xn, which is equal to n lambda capital D by small d. Similarly, for finding out the value of dark region, it will be nothing but x should be equal to xn, which is equal to n plus 1 by 2 lambda capital D by small d. Similarly, we found out that the consecutive difference known as the fringe width is always same for either bright fringe or either dark fringe, and that is equal to beta denoted by beta, which is also known as lambda capital D by small d. Moving on to the next concept now. So in the next concept we understood the concepts of if we understood it as lambda, and if we try to change the position of S to some, let's say S dash, so what will happen if we change, so it just gets reflected in the above position, or if we change it to this position then it gets reflected towards the lower position. So this concept was being explained in the last lecture only. Let's move on with the further discussions for today's lecture. So this thing is completed, this was the last point in the last lecture. Now let us move on to today's discussion now. Okay. So first of all let me explain the diagram here, what this diagram is showing. So a source is being kept here. So let us suppose that the source is being here, let the source be a bulb only. So this is the bulb, it is being emanating light, that source goes to a single slit here. Then because the single slit is being used and then that light is being moving toward these two slits known as S1 and S2, then the phase is always logged. That is, if the phase of this light going toward this S2 slit is, let's say, psi, then the phase of slit S1, light going through S1, will also be psi. So similarly after this interference happens and then the fringes are being formed on the screen. So this is the first thing being explained here, and after this the second thing is nothing but It just shows you this is the screen, this is the screen being shown, this is the screen being shown. These white color lines tells you about the bright fringes. Let me write the bright fringes as bright, and these are the dark fringes here. So this is nothing but dark. These are the dark fringes. So as you can see, consecutive bright fringe and dark fringe are available, and here you can see the intensity. Even you go far away from the center point, always the intensity is constant, which is equal to I max. Why I am saying, because here intensity is I max, because in further discussions of diffraction we will get to know that sometimes with the passage of, with the increase in the path difference, the value of the intensity keeps on lowering. Why it will low, why does it happen like this, I will explain, but for now just I need to explain you the diagram here, so that is been explained. Now let us move on to the discussion written in the left hand side. Okay. So we should mention here that the fringes are straight lines, quite evident, the fringes are straight lines, as you can see, even this is a straight line and even this is a straight line. Although S1 and S2 are point sources, so please make sure, because S1 and S2, so in the last diagram as you can see here, so this is being shown here, this discussion, these 2 point discussion is of last line only. So as you can see, both are a single pinhole, because it is a single pinhole, it can be understood as a point source. So these are nothing but point sources. These are nothing but point sources. Now we should mention that here that the fringes are straight lines, although S1 and S2 are point sources. If we had slits instead of point sources, each pair of points would have produced straight lines fringes, resulting in a straight line fringe with increased intensities. So this is nothing but the explanation being done here. So what was happening in the last line, whenever we try to find out the interference fringes in this pattern, general pattern is somewhat this. So this is the pattern when we try to use only a point source. So point source is nothing but if pinholes are being used. If, let me write here, if pinholes are being used, then this is the interference fringe we observe. But if we use a slit, what is a slit? Slit is nothing but, let me make it. So as you can see, if this is the screen, if this is our complete paper, let us say this is the cardboard, and if I make a single point source like this, then this is the simple experiment being shown by Young's experiment, if it is a single pinhole source. But here if a slit is being asked, then a slit is nothing but, so this, a small groove being made, a complete line is being made. So this, as you can see, this is also a straight line only. So when these are being used, then it is said that the fringes are formed in a straight line only, but those intensities are being increased. So intensities are increased. So this is a new concept we understood, that from the point sources, if the increased intensities are observed, then it is quite peculiar, it is quite possible that the intensities are due to a slit being formed. And please make sure that only a single slit won't be of issue, there need to be a single source of light with a single slit followed by 2 slits, then only this complete Young double slit experiment is possible. Okay, so this was the explanation for this part. Now let us move on to one of the example. So 2 slits are made 1 mm apart. So 2 slits, so these are the slits being set. So these slits are nothing but 1 mm apart, and the screen is placed 1 meter away. So this screen, so the distance from, let us say if I make it in 3D space, let us say this is the distance being talked about here. So this distance is given to you as 1 meter. As you can see that the difference between this and this is quite large. So because this is one of the assumption, to make sure that the formula we are using is correct, so we have to see that this small d, small a are always very less than capital D. What is capital D here? Capital D is the distance being talked about here. So this is the capital D for us. Okay, so this thing is also explained to you, that this is one of the assumption being explained here. So now 2 slits are made 1 mm apart and the screen is placed 1 meter away. What is the fringe separation when blue green light of wavelength 500 nanometer is used? So it is given that lambda is given to you. Please make sure nanometer is used, so we know that lambda is equal to 500 nanometers, and in nanometers if we need to convert it into meter, it will be nothing but 500 into 10 to the power minus 9 meters. So only simple explanation, as we know for the fringe spacing the formula is lambda capital D by small d. Therefore just putting the value of lambda as 500 into 10 to the power minus 9, capital D as 1 and small d as 1 into 10 to the minus 3. This is minus 3 here, the 1 was subtracted. So 1 mm is nothing but, if I just write it here, 1 mm is nothing but 10 to the power minus 3 meters. So just simple mathematical calculation gives you the fringe spacing as 0.5 mm. So what does this mean? This fringe spacing means that the distance between subsequent or consecutive bright fringes or consecutive dark fringes is nothing but 0.5 mm. So this is the second example. This may be asked in your exam, so please make sure, please remember the formula, simple mathematical formulation. Okay, now let's move on to one of the discussion I need to explain to you. So what happens, what are the effects on interference fringes if you try to move the screen or a monochromatic light is being used, etc. So please look over here carefully, it's a very important, very interesting concept. So what is the effect on the interference fringes in Young's? Please make sure it's a double slit experiment. What does double slit experiment means? That this is the concept being talked about here. This is a double slit experiment. So what is the effect of the interference fringes in a Young's double slit experiment due to the each of the following operations? So different operations are being done and then we need to calculate or we need to find out what are the effects. So I will go line by line and then try to explain you everything. So first is the screen is moved away from the plane of the slits, that the screen is moved away from the plane of the slit. So what happens in this case? Let us see the discussion which is written. Okay, in each operation, please look at the last line here. The last line is written that in each operation take all parameters other than the one specified to remain unchanged. That means if the screen is moved, then everything remaining apart from this value is always constant. Okay, so angular separation of the fringes remain constant, as quite evident that if the screen is only the s value is changed, the angular separation is always constant, which is equal to lambda capital D, lambda by small d. The actual separation of the fringes increases in proportion to the distance of the screen from the plane of the two slits. So as the value of angular separation, let me write the angular separation as theta is directly proportional to lambda. That means the actual separation of the fringes increase in proportion to the distance of the screen from the plane of the slit. So if the capital D changes, then only this actual separation, let me write the separation as like this, separation increases in proportion. So it is directly proportional to each other. This is one of the effect if the screen is changed. Moving on to the next part. So if a monochromatic source is replaced by another monochromatic source of shorter wavelength. So this time nothing is being done, the source was kept intact only, but this time only the value of lambda is being decreased. So what happens if the value of lambda is decreased? So the separation of the fringes decreases. See, however, the condition below and D below. So first of all, so let me just explain you till this part only. So as we know that for fringe width the formula is lambda capital D by small d. So quite evident, if the value of wavelength is being decreased, then the value of fringe width will decrease. If the value of fringe width will decrease, then the difference, then the consecutive difference between the bright fringe and the dark fringe will reduce in its shape. So this is only the explanation, this is only one of the effects which will be observed. So what will happen? So just let us suppose that if this the distance between consecutive dark fringe or consecutive bright fringe is let's say 1 mm, then this distance, if the wavelength is being changed, maybe this will change to into 0.5 mm. So this is the explanation being talked about here. After the explanation of D, we can directly go to this part if I need to explain this concept also. But for now, we understood that the separation of the fringes decreases. Moving on, the separation between the two slits is increased. The separation between the two slits is increased. Quite evident that here again we need to find the concept of effect of interference fringes. So as you can see, the separation of the fringes, or also known as angular separation, decreases. So what is happening in this case, I will explain it here only. So again we know that fringe width is nothing but lambda capital D by small d. As the value of D is decreased, D is nothing but the distance between the two slits. If this is increased, the question is saying that it is increasing. So if this is increasing, then the value of beta will decrease. So it is written the same, that the separation of the fringes decreases. So this thing is also explained to you. Now move on to the next part, that is D. The source slit is moved closer to the double slit plane. So what does this mean? This means just that let us say that the distance between this and this was given to you as, let's say, some length capital L. Now this length is being changed into some L dash, where this L dash is less than capital L. So this is being talked about here, everything else is kept constant. So now what happens in this case, the source slit is moved closer to a double slit plane. So please make sure, please look over this line carefully. Okay, so the saying that let S be the size of the source and capital S be its distance from the plane of the two slits. So capital S, so if the distance which I am saying was capital L, here it is given or denoted by capital S. So let S be the size of the source and let capital S be its distance from the plane of the two slits. For interference fringes to be seen, the condition that is capital S, small s by capital S should be less than capital D by small d should be satisfied. So this is one of the condition, or in another case I can say that small s should be less than capital S lambda by small d. So you need to just remember this is one of the condition. This is the condition needed for the interference fringes to be formed. If this condition is satisfied, only then the interference fringes will be visible. Otherwise, interference patterns produced by different parts of the source overlap. So why is this condition important? This condition is important, otherwise what will happen? The interference pattern will overlap. So any dark fringe will come in the place of white fringe, so the color combination will happen and there won't be any visible interference fringes. And no fringes are seen, quite evident. If there is a mixture, then there is no fringes being observed. Thus, as capital S decreases, the interference pattern gets less and less sharp, and when the source is brought too close to this condition to be valid, the fringes disappear. So this is same thing only. So as long as this capital S is trying to be intact, so this, let us say this is the capital S, if we try to decrease it to, let us say, S dash, what will happen is the sharpness of that screen's visibility of the interference fringes will get less and less sharp, and at one point there won't be any interference fringes. So this is only being observed here. So what, nothing, anything more to be told to you? Till this happens, the fringe remains fixed. So till this happens, so till that some point S, the fringes remain fixed, so the fringes are available, but after that they won't be available. Okay, so this is that point. After this, next is, so this point is also done. Let's move on to the last two concepts. So next is the width of the source slit is increased. The width of the source slit. So width of source slit is then as in this, the width of this slit, with the width of this first slit, which is the source slit, is being increased. What will happen in this case now? So same as in D, as the source slit width increases, the fringe pattern gets less and less sharp. Quite evident, because as we should know this concept that these fringes are only and only observed when the amount of the slit is very less. We understood this concept by the first assumption that small d and small s should be very less than capital D. Similarly, this case should also be available, that is fringe pattern will get less and less sharp as the width is being increased, because if the width is increased, then the range of the wavelength and the diameter size is varying. It is varying with large what we can say, let us say if something in the power of 10 to the power minus 9, and if the object is not in the same power, let us say it is in 10 to the power minus 7, or let us say in 10 to the power minus 5, the amount of size is varying. It is only applicable, the interference fringes are only and only visible when the wavelength is in applicability or is in same order as that of the object through which it passes. So that is why if the width is being increased, if the order is being increased, then the fringe pattern will again get less sharp. And when the source slit is too wide, if it is so wide, then the condition again S by S is less than equal to lambda capital D by small d not satisfied, hence the interference pattern disappears. So one of the concepts which we need to understand from this is that we should remember this condition. The condition says that small s by capital S should be less than or equal to lambda capital D by small d. So this is one of the inference we got from this complete concept, that is small s by capital S should be less than or equal to lambda capital D by capital lambda by small d. Okay, let us move on to the last concept here. The fifth one says that the monochromatic source is replaced by a source of white light. So as we know that a source of white light is a combination of many wavelengths of light. So what will happen if we change it to monochromatic light? So the interference pattern due to the different components colors of light overlap, quite evident, because different wavelengths will be happening, and hence there will be an overlap of all the different wavelengths on the screen of light where the interference fringes is being formed. The central bright fringe for different colors are at the same position, quite evident. Therefore, the central fringe is white, because everything gets mixed up in the center position, because the angular separation is same. Therefore, because there is a mixture, the white light is visible. But what will happen in the subsequent part differences? For the point P, for which S2P minus S1P is equal to lambda B by 2, where lambda B we are assuming that, let us say it is 4000 Armstrongs, represent the wavelength of blue color. The blue component will be absent and the fringe will appear red in color. So where the wavelength of lambda by 2, we know that for destructive interference to happen, the wavelength part difference should be equal to lambda by 2. So if lambda by 2 is equal to the wavelength of blue color, then the blue color will not be visible, hence the color visible there will be red. Similarly, if we use farther away such that the value of lambda r by 2 is visible, that is lambda r is nothing but the wavelength of red color, then at that point again destructive interference will happen for red color, and hence red color will not be visible, and similarly blue color will be visible there. So the fringe will be predominantly blue, thus the fringe closest on the either side of the central right fringe is red and farthest will appear blue. After a few fringes, no clear fringe pattern is seen. So this is being explained to you right now, but I will again start from this F point in the next lecture. For now let me stop it here only. So in this lecture we understood the concept of complete Young's double slit experiment and pinhole experiment was being concluded, and finally we understood some of the effects of monochromatic light or the change in the shape or the change in the lambda capital D value or small d value, etc. Finally it was being explained that what will happen if the source of white light is being used in place of monochromatic light. I will try to explain it more detailed in the next class. For now let me take a stop here only. So thank you.